Okay, so we've got a camera here, and the race car is moving, and we're told that the race car is moving at a rate of 180 miles per hour, which is 264 feet per second. Let's do all our problem, all of the units in feet, to make things easier. So, since I've declared the distance here to be x, I'm going to then say, well, that's what we have is that dx dt is 200. What did we say? 264 feet per second. 264. Make that look more like a 2. We're doing it in black. All right. And then the questions that they're wanting us to solve is how the camera angle is changing. How would I describe the rate at which the camera angle is changing in symbols? D theta dt. The rate at which the angle is changing, and the angle is measured as the variable theta per time. All right? And they want us to do this when time is equal to, or when the camera, or when the car is directly in front, when the camera is, or the car is directly in front of here. I'm going to say that means we want to find that value when x is 0. All right? So that's the question they're asking. Now the question is, can we put these things together into an equation, which we then can take a derivative of, which we then can plug and chug on. All right? So what kind of relationship do we see between theta and x? And the one other piece of given information, which is the 132. That's exactly what I would use. I'd say that the tangent of theta is equal to, and what is it? It's opposite over adjacent, is equal to x over 132. Which, by the way, could clean up as 132 tangent theta equals to x. We might find it a little easier to take the derivative that way. Right? Now again, we want to suppress the urge to put 0 in for x right now. We'll do that after we take the derivative. So what is the derivative of 132 tangent theta? 132 secant squared, perfect. Chain rule. Yeah, d theta dt. And what's it equal to on the other side? Dx dt. Take the derivative of both sides of the equation with respect to t. Interesting. It looks like it looks like the x doesn't matter. But that won't match my answer. Oh, there will matter. Okay, the x value won't matter, but the theta. Okay. All right, let's go in the plug and chug for this. We want to find out what is the value of d theta dt when x is 0. But you know what? When x is 0, when the car is right there, we also could say what value theta has at that time. 0 as well. So our plug and chug step says, okay, the 132 is a constant. Secant squared of 0. We don't know what d theta dt is, but we do know what dx dt is. It's 264. I think I got all my plugs and chugs in. Well, I got my plugs in. Now time to chug. All right. What is the secant? What is the secant of 0? Let's see. If cosine looks like this, doesn't secant look like that? Like that? at 0, 1. So 132 times 1 squared times d theta dt is equal to 264, or d theta dt is equal to 264 divided by 132, which is 2. And what unit is this going to be in? It's going to be in radians per second. To change in how the angle is going per time. Since we're using s for, or our time is in seconds, that's fine. All right? And so there's our value when x is 0 and when theta is equal to 0. Now they have another question, and that is, what about a half second later? What is going to be this a half second later? What is the angle? How's the angle going to change? Well, where is the car a half second later? It's no longer here. A half second later, it will have moved 132 feet. If it's moving 264 feet per second, a half second later it has moved half that distance. So we're going to say when x is 132, now what angle theta do we have at that point? Well, we've got a opposite side of 132, you've got an adjacent side of 132. That would be, well, that would be a 45-45. It's a right isosceles triangle. The ratio of the opposite sides of the adjacent side is 1. What angle does tangent have when 45? Yeah, 45. So this is going to be when theta is pi over 4. That's our new question. Well, let's plug and chug. 132 times secant squared of 45 times d theta dt is equal to 264. Okay, now what's the secant of pi over 4? Draw my reference triangle. Here's a pi over 4 angle. And secant is hypotenuse over adjacent, square root of 2. So we got 132 times the square root of 2 quantity squared d theta dt is equal to 264. So that's 132 times 2 times d theta dt is equal to, sorry, change that, lost a 4 there, 264. That's 264 times d theta dt equal 264. I think you can see that d theta dt is going to end up with 264 divided by 264. It's going to be 1, and our unit again is going to be radians per second. And that's the answer to our B question. The value of d theta dt a half second later. Let me turn on. Are we okay with this? Okay. I just want to stop the recording.